Today, I'm going to be explaining what water ice is. One of the reasons why I was inspired to talk about water ice for this project was because in a lot of the Space Journal Club presentations, water ice was mentioned as being a source of fuel for different missions, rockets, yada yada yada, all these things that I never learned before. And so this is a perfect opportunity for me to learn more about it. So, what is water ice and where can it be found? Water ice and water vapor can be found on some of the terrestrial planets and satellites in our solar system. It appears on a planet or satellite as ice below and or near the surface. And recently, water ice was found on Mars and at the poles of the moon. So here's a very badly drawn image of the two poles of the moon and water ice present. How is water ice used in space exploration? Liquid hydrogen is an extremely powerful and light rocket propellant. When combined with the oxidizers such as oxygen, liquid hydrogen gives the most efficiency in relation to the amount of propellant used. And so when we first mine water ice, it's in a solid form, but we can make it into a liquid form. So, although it's a very useful resource for space exploration, there are many challenges that come with it. So, both liquid hydrogen and oxygen are cryogenic, which means that they can only be liquefied at extremely low temperatures. This fact poses challenges to using liquid hydrogen and oxygen as fuel. Liquid hydrogen must be stored at negative 423 degrees Fahrenheit. Therefore, to make sure it does not evaporate, rockets fueled with liquid hydrogen must be insulated properly to keep away all sources of heat, including the heat of the sun. When liquid hydrogen absorbs it, it expands, so the necessary venting is key to ensuring that it does not explode. If metal is exposed to the extreme colds of the liquid hydrogen, it becomes brittle, further damaging the material. And finally, liquid hydrogen can also leak out of small, minute spaces in the welded seams of the metal, so once again, it can lead to the metal being damaged. So what's the significance of finding water ice on the moon for deep space exploration? Well, if we were to look at a water molecule, besides just using the water ice found on the moon for astronauts to drink, if we split the water molecule into hydrogen and oxygen atoms, 2 hydrogen, 1 oxygen atom, the hydrogen can be used as fuel for rockets. And as written in a tweet by NASA's Associate Administrator of Science Mission Directorate, Thomas Zurbuchen, with enough ice at the surface, water would possibly be accessible as a resource for future expeditions to explore, and even stay on the moon. And so, if you think about it, the moon could become a gas station for us. So this brings me to my next point. Finding water ice on the moon can also help us achieve the goal of making it to Mars. By having a gas station in space makes it easier to explore deep space and allows us to move away from bringing all the necessary fuel from Earth with us to where we need to go, but rather we can just make a pit stop at the moon very quickly and fuel up before moving on. I think it'd be really funny to see a chevron sign on the moon. I doubt that would happen. But there's still much to learn about how deep the water ice is on the moon and how we will be able to move forward and extract it. I think it's really important to keep in mind how we're going to be able to make sure that we're extracting water ice in a respectful way that doesn't damage the moon, like we've done here on Earth and with our environment. So thank you so much, and I hope you learned a lot of new things about water ice and why it's useful and how it's going to help us propel us into the next generation of deep space science exploration.